Hi, everybody. What we're going to be learning about today is something called the greatest integer function. This is a function that is discontinuous, which means we will have to pick our pencil in order to graph it. So we can graph part of it and we have to pick up our pencil to graph another part of it. So that makes it a discontinuous graph or discontinuous function. And when it's all said and done, it's going to look like a set of steps. Now, each year I kind of use the same example. And that example is if you were saving money, think about if you were saving change in a jar and you were told by someone, hey, when you get a full 100 cents, I'll give you a dollar bill. So I want you to think about this. If you had, say, 23 cents, how many full dollars would you have? Well, you would have no full dollars. Okay, and let's even go back a little bit. If you had no money, you have no dollars, right? So that's this point right here. So as you're saving your pennies, you're saving. Maybe you have 50 cents now. You still don't have any full dollar bills, right? $0. Maybe you have 95 cents, but you still don't have any dollars. So we're still here down at, we're saving our money, but we haven't jumped up to a dollar yet. At 99 cents, you still don't have a full dollar. But as soon as you get that last penny, we don't have a point here because now you have a full dollar. And now you start saving your money again. So you have $1.10, $1.20, $1.50, $1.60, $1.70, $1.88, $1.99, and then boom, you get that last penny. And now you have $2 bills. And this pattern continues, open circle to the right, because that's when you jump up a level and get that dollar bill. This is the parent function for the greatest integer function. Now, I gave you an example about money, but this pattern does continue back this way. Okay, and so our real life example about money doesn't apply probably to these negatives, but I just wanted to give you an example, something to think about. We can all think about money. So this is what our parent function looks like. Whoops, I don't know why that came up. This is what our parent function looks like. So a couple things I want you to think about. Every single step has a closed dot here and an open dot on the right side. I also want you to notice that the first step started at 0, 0. And the other thing I want you to know is that if we were to kind of look at this, notice that they're not connected, but it has a slope of 1/1, which is actually a number from right there, right in front, our coefficient. Now, you're going to be able to put this in your calculator. I can teach that to you in class. But what I want you to know is that all of the transformations that we've done for all of the other functions work exactly the same here. So we know that by adding 2 inside the brackets, we're going to I'm hitting some buttons here. Let me fix my computer. We know that this is going to translate to the left 2 units. And we know that by subtracting 3, we would take that initial step and we would translate it to the right 3 units. Okay, so that's our opposite. We talk about opposite and same. If we add 2 outside of the function, we will translate it up 2 units. And if we subtract 3 after taking the greatest integer, we're going to translate it down 3. When we have a coefficient in front, it's going to stretch it or make it taller. But what I want you to think about is that that is going to be our rise. So our rise between our steps is going to be twice as tall as the rise between the parent function steps, which were just a rise of 1. Okay, almost like you're skipping steps. If the number in front, the coefficient in front is 1/2, that's going to shrink it. Okay, it's going to make the steps really short. So the rise between the steps is only going to be 1/2. Now, don't think you're going up 1 to the right too. Instead of going up 1, you're going up 1/2, and then your next one will start. So we'll talk about that when we get there. And the negative, as usual, is going to reflect it vertically. So instead of our steps going this way, our steps will be going this way. Okay, so all of that's old news. So let's go ahead and let's do this example right here. Okay, so what I want you to do, thinking about all that you know about transformations, I want you to pause this video and I want you to tell me what the 1/2 will do. Oops. I want you to tell me what the 4 does. And I want you to tell me what the -3 does. Okay, so you go ahead and pause this video and tell me what you get. Okay, so hopefully you got what I got. Now, what we're going to do is we're always going to have to figure out where our initial step will be. So remember, the parent function started at 0, 0. This one is going to start at -4, -3. And here is our first step. Now, what I want you to do when you do these problems is I want you to put a little star over the first step. Okay? From here, we have to apply the rise of 1/2. So from here, we only go up 1/2. And then we have our step. And then from here, we go up 1/2. And we have our step. And I want you to notice that there's no x value that is not included. We jump from here to here. So we have x equals 3 in our function. I'm sorry, -3. -3, -2.5. -2, -2, and so on. So this is what our function looks like. Now notice, you don't really have to put that big meatball on the left side. Okay, if you want to just do something like what I'm doing right now, that would be fine, because I know if there's no open circle there, there must be a closed circle there. Oops. And I do want you to go all the way left and all the way right. Okay. So that's all you need to take notes on today. You're going to submit this, and then we will jump right into this when we're in class next. Have a wonderful day, everybody.